Hello, my name is Kewalin Samart. I am an undergraduate student majoring in computational mathematics with a minor in computational math science and engineering at Michigan State University. I'm working in the Jeravi and Krishna labs at Michigan State. Today, I'm very pleased to present our recent work on reconciling multiple connectivity scores for drug repurposing. I worked on this project with Phoebe Tayashime, Dr. Stephanie Lepsicki, Dr. Arjun Krishnan, and Dr. Janani Ravi. Computational drug repurposing has been an efficient alternative for drug discovery since it is both cost and time effective compared to the traditional drug discovery that requires a significant amount of time and budget. The key principle of computational drug repurposing is that the efficacious drug will successfully reverse the disease signatures. And one of our ongoing projects in the lab is drug repurposing project, as we develop a computational approach to repurpose drugs against infectious diseases. And last year, when my teammate and I were reading paper after papers, we have found that over the past 15 years, many methodologies have been developed towards finding disease-drug reversal relationships. And this is the timeline with all of the connectivity score and similarity metric that have been proposed by different studies within the past 15 years. And then we decided it would be very helpful if we reconcile all of these different disease drug connectivity score, because although these have been built upon the same set of mathematical and statistical concepts and ideas, they have been described using inconsistent notation and terminology. So it would be really helpful if we reconcile all of these connectivity scores using our own notation and terminology that is more consistent, so we can define their relationship to provide deeper insights into existing methods. And the key concept of calculating connectivity score is to find similarity between disease and drug gene expression profiles. In order to do that, we compare similarity between disease and drug profile, start with a rank order disease gene list and a rank order drug gene list. The disease-drug association can be determined based on position membership and gene expression value of disease gene that appear in the drug profiles. In the middle here, we have a taxonomy of connectivity score. We lay out every single connectivity score and establish their relationship and connection. As a result, we have found that each of the connectivity score built upon similarity metrics, and different choice of similarity metric can also influence the nature of the connectivity scores. In panel B, we have some of the mathematical formulation that we redefine all of the score using our unified notation and terminology. We also noticed that each of the similarity metrics that have been proposed in the past decade require different amount of input information, and depending on the disease and drug information that they require for the input, those choices also influence the symmetry property of each of the metrics. So the one with symmetry property means that we can use that metric to calculate not just only disease drug association score, but also disease or drug association score as well. In conclusion, connectivity score differ from each other in their choice of specific similarity metrics and how they are combined, normalized, and background corrected. The choice of similarity metric significantly influences the nature of the connectivity scores. In general, a lower negative score indicates a better reversal, and the way that we threshold input disease data also affect the performance of the connectivity score. And after we defining all the connectivity score using our unified scheme, this attempt will improve the consistency of future methods with existing one and will help clearly establish the origin of analytical ideas. Right now, we are working on integrating all this method for gene expression-based drug repurposing. And we hope to build an infectious disease database. Also want to implement all the multiple metrics in an R package. So it could be later used in the future drug repurposing research. And if you're interested, I would like to invite you to read our paper that recently published in Revering in Bioinformatics Journal. And to facilitate the continuous and the transparent integration of newer methods, this article will also be available as a live document and coupled with GitHub repository that any researchers can build on and put changes to the link are provided here. I would like to thank all the funding, and lastly, would like to acknowledge everyone in the Jeravi and Krishna labs for their guidance and support. Also, the ISMB ECCB 2021 for the opportunity to present my research today. And if you have any question, feel free to contact me. Here's my contact, or you can contact my PIs. The emails are provided here. Thank you so much for your interest. Bye.